In our last video, we made some really annoying noises and looked at how the oscilloscope can monitor audio signals. In this one, we're going to take a look at something that's pretty practical to everyday life. We use USB chargers a lot, and you can get them in all different sizes and shapes. In fact, those two shapes right there are pretty common. You can get portable USB chargers, about like so, and you can get different quality. I've got one plugged into the wall right here, and you can see that right now it's generating 5.17 volts, and it's providing 0.72 amps to this little resistor circuit that I've hooked up, and I've written 1 amp and 2 amps on there. Theoretically, that's what it's going to charge because I've got two 10-watt resistors. When I throw that into parallel, those two resistors, each one's 5.1 ohms, and now they're in parallel, so I should be getting 2.5 ohms of resistance right here. You'll notice I'm not getting a full 2 amps going right there, and a little bit of that, well, we'll take a look at what's going on in the circuit. But we can see I'm getting about 3/4 of an amp through that resistor right now, and it's delivering 5.17 volts. That's excellent. Standard for USB charging should be between 5 and 5.25 volts at all times. Your phone will be really happy with that. Some phones now have moved to more advanced rapid charging algorithms. So, for instance, the latest Samsung lines come with a USB-C charger. USB-C is an advanced platform, and you actually have communication taking place between the device being charged and the power supply on the wall, and the device says, hey, I need this many volts, and this will deliver up to 20 volts for charging, and it can deliver up to 5 amps depending on your power supply. Your power supply might say, no, I'm a 1 amp charger, here's your 20 volts at 1 amp, and you'll charge at 20 watts, which is a lot better than our standard USB. The original USB standard was 5 volts, up between 5 and 5.25, 5 volts at 500 milliamps, so only 2.5 watts of charging. It would take a long time to charge your phone at that rate. It didn't take long for them to realize that they needed more than 500 milliamps. A lot of computer outputs still only deliver 500 milliamps, but your chargers quickly moved up to a 1 amp charger, so that would be a 5-watt charger. 5 volts times 1 amp is 5 watts. And then we moved up to the 3 amp chargers, so 5 volts times 3 amp, giving you 15 watts coming off the charge. Samsung came up with their own protocol, so their chargers would talk to their devices, and their USB chargers would check to see if they were hooked up to a Samsung device, and they'd say, oh, I can give you 9 volts instead, and they would charge a little bit faster. But now the USB-C standards really cleared all that out, and you can get enough power off USB-C to run a laptop, let alone recharge a phone. So here we go. Power's coming out of the USB charger. This is telling me I'm getting 5.2 volts right here. I'm delivering 3/4 of an amp. Let's take a look at what that looks like on the oscilloscope. So here's my charger, or my fake phone. It's just a couple resistors so that we don't have anything fancy going on in the way of communication right there. Hook one side of my probe to one side of the resistor, one side to the other right there, and let's turn on the scope and see what we get for a signal. The ideal signal will be a perfectly flat line across the top, and it will be pretty close to 5 volts. So the scope is booting up right here, and it takes a minute for it to go through and do all of its startup checks. And in just a moment, it's going to ask us to push a button. There we go. So it's passed all its tests, and we can press any button to continue. So I press a button right in there, and bang, here we go. Let's just check and see where our 0 line is right now. I'll just disconnect from right here. There's our 0 line on channel 1 is sitting right down there. I'm at 2 volts per division. If I want to see this a bit more clearly, what I can do is I can lower the bottom line for 0 to come all the way down here. And, well, let's just set it right there. And then I can zoom in. Now I'm at 1 volt per division, 500 millivolts per division. So if I was getting 5 volts, that would be half a volt, 1 volt, 1.5, 2, 2.5, 3. No, a little too much. I better stick at 1 volt for division. So a proper 5 volt signal will be 1, 2, 3, 4, 5, right up to there. Okay, well, let's hook on to here and let's see what we get. Now you do see a little bit of ripple happening there. That's just ambient noise. If you touch it with your fingers, your body actually acts as a conductor. This is how sensitive an oscilloscope can be. It can pick out the 60 hertz frequency of the electronics and the wires around you pretty simply. Let's clip on right there. Get a nice strong signal. You got to have both the ground and the supply connected right on there. And look at that. That is a rock solid signal right in there. Now we're at 1 volt per division. This is our baseline for channel 1. So 1, 2, 3, 4. We're not quite at 5. That's like 4.6 volts in there somewhere. We do have a measurement tool that would allow us to read that really accurately. May start to flash that up on the screen for us in just a moment. But we're seeing a lower voltage out here because there's also voltage drop in this device right here and in this line right here. So when people are selling good charge cables, getting the cables with the 24 gauge charge cable is a lot better than getting ones with the 28 gauge charge cable, because you'll have less resistance in the line, less voltage drop when it comes right out to here. So let's take a look now at what's going to happen. I'm going to boost the load on it, and now I'm using both resistors. You saw that voltage drop down, and by the time it gets out to here, I'm only at 1, 2, 3, 4 volts. So I'm losing energy in this line somewhere in the neighborhood of 1 volt as we go through there, and I'm putting 1.42 amps through it. So out at your phone, you get 1.42 amps because there's nowhere for this to go. It's all in series, but you'd only be getting it at 4 volts. So you'd be getting about 5.6 watts of charging right there. Still not bad. My little resistors are getting nice and warm right in there. Let's take a look at a few other chargers, and I'll take this one out right now and we'll just check the specs on that. It's an aftermarket one, CE Tech. It doesn't really say anything on the back. More information on the back right here. Yeah, just a standard wall charger. It says it's rated up to 2.4 amps, so we weren't really challenging it too much. Now, here I've got two that look identical and will probably be familiar to people who own Apple devices. And looking at them from the outside, they don't look that much different. And I can tell you that I purchased one of these at the night market, and the other one came with an Apple device. And if we look at the back of them, let's bring that in a little closer right here, see if we can get a nice focus on there. And what we're looking at right here is this one over here actually has the Apple logo, and it says designed by Apple in California. And this one right here, if I turn it upside right, says power adapter. Did they even spell adapt? It says power adapter, made in China. Might tell you something right there, but they even went so far as to copy the little green dot that Apple was putting on some of their devices for a while. And so this is a knockoff. This is an original. Let's take a look at what the original does and how that shows up on our scope. So here's our original, and it took a second for that multimeter to boot up, and let's bring our focus back in right there. So we're getting 5 volts, 0.7 amps, and when we look at our oscilloscope, nice steady signal coming along right here. You know, as I play with my time frame on there, it really doesn't make any difference. That is a DC signal. It's rock solid at 1, 2, 3, 4.4 4.4 volts. So slightly less voltage than the other charger, but it's doing fine. And if we jack it up to a couple of amps, well, we're not delivering quite as much current right here. You can see our voltage dropped off. It's a smaller charger. It's struggling, having a little bit more difficulty on there. But let's just look at that screen, and you can see that it is a perfectly flat, perfectly level signal coming right in there. So the Apple Charger is doing pretty good. Let's take a look at the knockoff, because the Apple Chargers are like 20 bucks or something like that. The knockoff, I got it for $3. Did I get a good deal? Put this back to the 1 amp setting and start off easy on it. Oh my. Now the first thing you'll notice is that we are getting some signal coming out right here. And you'll notice it doesn't look anything like the signal that we were getting coming to the other two chargers. And in fact, it's not even showing up on here as a noteworthy charge. Now this is moving off to the side. That's because our trigger level is set a little bit low. So let's bring our trigger right up here, and we'll catch that right now. And now what we can see is we can see that it's actually giving us a frequency on here. It's so noisy that it can pick up the 60 hertz frequency that's coming in from the wall power. And it's giving us between 2 volts and about 3.2 volts where it comes out. It's it's averaging about 2.6 volts where it comes out to our charger, and that's on the 1 amp setting. If I hit it up to the 2 amp setting, what the heck is that? Let's zoom in here. Can we stop it right there and freeze that screen? We can zoom in a little bit more on that signal, and you can see a whole bunch of little noise going on right here. Now we're getting less than 2 volts coming out there. Your phone would reject that, just like this charger, or this voltmeter is rejecting that, and it's not displaying anything. There's no way that would work. It might work, and it might give you some juice if you were to charge at the slower 1 amp setting. But basically, it looks the same on the outside. But yeah, put that in the night market, and you just sold someone a piece of garbage. They won't know about it till they get home and their phone doesn't charge properly, or their phone takes forever to charge. Let's take a look at some of these portable chargers, because all they are is a battery. And this one, it's probably got 2 batteries inside of it, with a little voltage regulator that should give us a 5-volt output. And so I'll hook this up on here and start it up. Give it a second to start up here while it's getting booted up. And so this portable charger's doing just fine at the 1 amp setting. On the oscilloscope, nice flat signal. And if I hit it up to the 2 amp setting, well, I see a voltage drop, but this is still giving me 5 volts right at the source, even though actually I'm getting pretty similar output from that battery pack as I did from this wall charger. So, you know, again, it's not a brand name or anything like that, but you know, it looks like it passes the oscilloscope test and is a pretty good looking charger, both at the 1 amp and 2 amp settings. I've got another one right here. This one, oh, now Microsoft didn't make these. These were giveaways at a Microsoft event that I was at. But let's see, did they purchase a good device to give away, or did they end up going to the night market to pick these up? So plug it in on the 1 amp setting, and oh, well, it probably helps if I charge the battery before I do the test. So that was a little unfair to Microsoft. If I don't charge their battery, I don't expect it to work. That's on me, not on them. This one's got a Duracell brand name on it, though. Duracell felt happy to sell these, and it looks like it's got 3 bars of charge on it. Well, let's see what it does. It's only got a single battery, but giving me nice stable voltage. 5.15 volts, 0.7 amps. If I bump it up a notch, the voltage comes down a little bit. There's probably some internal resistance in that single battery. But you know what? That would probably charge your phone. 1, 2, 3. It's down to 3.5 volts by the time it gets out to your phone. You might be having some difficulty getting a good fast charge off of this device. You could certainly help yourself by having a short cable with 24 gauge or 22 gauge, if you can find them, cables for the voltage lines. And like I say, keep that cable short, keep those wires thick. You'll see less voltage drop in the line. And whatever you do, just watch which chargers you buy, because there are differences even amongst the ones that look the same. So there we go. Great use for the oscilloscope. Put a load onto your power supply and check it out. In TTED 4060, we are going to be building our own power supplies, and you'll be able to test them and see if they stand up to a professional quality one, an Apple quality one. Actually, that was the night market one. I can't tell the difference by looking. Or the night market quality one. I think you'll be relatively impressed with what your handiwork can do. Thank you very much, and see you in the lab.